Now we are going to see about the underground cable used for electrical power transmission or distribution systems. This is a structure of underground cables. What are the requirements, the necessary requirements for underground cables? Conductor used in cables should be tinned, standard copper or aluminum of high conductivity. Conductor must be flexible and carry more current. In the structure of underground cables, having the conductor, paper insulation, lead sheath, bedding, armoring and serving. About the conductor is the core or conductor. A cable may have one or more core depending upon the types of service for which it is intended. The conductor could be aluminum or copper and is stranded in order to provide flexibility to the cable. About the insulation, the core is provided with the suitable thickness of insulation depending upon the voltage to be withstood by the cable. The commonly used material for insulation are impregnated paper, varnished cambric or rubber mineral compound. About the metallic sheath, the lead sheath or metallic sheath. A metallic sheath of lead or aluminum is provided over the insulation to protect the cable from moisture, gases or other damaging liquids. Over the insulation, the lead sheath is provided to protect the conductor and insulation materials. About the bedding, after the lead sheath, the bedding is provided. Bedding is provided to protect the metallic sheath from corrosion and from mechanical damage due to armoring. It is a fibrous material like jute or Hessian tape. After the bedding, the armoring is provided. The purpose is to protect the cable from mechanical injury while laying it or during the course of handling. It consists of one or two layers of galvanized steel wire or steel tapes. The final of the underground cable path is serving to protect armoring from atmospheric condition. To protect armoring from atmospheric condition, a layer of fibrous material is provided. That is called the serving. The next one is the oil-filled cable. The oil-filled cable are adapted for voltages beyond 66 kV. For natural cooling is not suitable to above the 66 kilowatt cable, because conventional solid type cables like belted or H type cannot be reliable to withstand the very high electric stress at such voltages. About the voltages, the low tension up to 1000 volt, the high tension up to 11 kV. Super tension from 22 kV to 33 kV. The extra high tension EHT cables are from 33 kV to 66 kV. Then extra super voltage cables beyond the 132 kV. In the oil-filled cable shown in that figure, in central part is the oil duct is provided. In this duct, the oil is flowed. The channels or ducts are provided in the cable for oil circulation in that center part. The oil under pressure is kept constantly supplied to the channel by means of external reservoirs. Oil under pressure compresses the layer of paper insulation and is forced into any voids that may have formed between the layers. Due to the elimination of voids, oil-filled cables can be used for higher voltages, the range being from 66 kV up to 230 kV. Above the 66 kV, we are using the oil-filled cable. And also oil-filled cables are of three types: single core conductor channel, single core sheath channel, and three core filler space channels. The oil channel is formed at center by stranding the conductor wire around the hollow cylindrical steel spiral tape. The channel is made of spiral steel tape. It allows the oil to percolate between copper strands to rapid insulation. The oil pressure compresses the layer of paper insulation and prevents the possibility of void formation. The system is so designed that when the oil gets expanded due to increase in the cable temperature, the extra oil collects in the reservoir. When the cable temperature falls during light load conditions, the oil from reservoir flows to the oil duct. Then property of various insulating materials used in underground cables and recommended most suitable materials for high voltage operations are: the insulating material properties are high resistivity, high dielectrical strength, low thermal coefficient, low water absorption, low permittivity, non-inflammable. Thank you. And sulfur